Good evening, children.
Good evening.
Good
Good
evening.
evening, ma'am.
Good evening, ma'am.
Evening. Good evening, children. I was stuck with some issue with my laptop, so I was just fixing it all the while. Yeah. So I think in the last class, we discussed the answers to question number 1, sorry, subdivisions 1 and 2, right? And the rest of it I gave you as homework. Am I right?
Yes, ma'am.
Yeah. Completed?
Yes, ma'am.
Yes, ma'am. Okay. All right, let's see this one. So the denominator clearly is irrational. The denominator is clearly irrational. So we need to rationalize the denominator. The conjugate of root 5 plus root 2 is root 5 minus root 2. So we multiply this is the given expression. We multiply the numerator and denominator by the conjugate root 5 minus root 2. So see here, this is the given expression. The denominator is irrational. The denominator is irrational. So we multiply the numerator and denominator by the conjugate of the denominator, which is root 5 minus root 2. That's the first step. Next, we multiply the numerators, we multiply the denominators. We multiply the numerators, we multiply the denominators. So 6 into root 5 minus root 2 is written like this. And when you multiply the denominators, clearly they are of the form a plus b into a minus b. Because you can see that in both the brackets, the terms are the same, root 5, root 5, root 2, root 2. Just that they are separated by a plus and minus sign. Plus in the first bracket and minus in the second bracket. Am I clear and audible, children?
Yes, ma'am.
Yes,
All right,
Yes,
children.
ma'am.
All right. Yeah. So a plus b into a minus b is a square minus b square. That's what you see here. Next, what you must remember is don't multiply in the numerator. Don't multiply. See, actually, the next step you would have thought I should multiply 6 into root 5 and 6 into root 2. That's what it means. When you have a 6 outside here, the next step is to multiply 6 into root 5, 6 root 5, 6 into root 2, 6 root 2. But don't do that here. Why? We'll just wait for, the denominator to happen. Once we get the denominator, we'll see if we can simplify the denominator and 6. The denominator and 6. So don't multiply. At this stage, you don't multiply. Write it as it is. Write the numerator as it is. See the same numerator. Write the numerator as it is. The denominator is root 5 square is 5. Root 2 square is 2. And 5 minus 2 is 3. See, in this step also, we have not multiplied the numerators. We haven't multiplied. Because we're just waiting for the denominator. We're just waiting for the denominator. Now the denominator is 3. And you can see that 3 and 6 can be simplified. 3 ones are, 3 twos are. So the denominator is now 1, which you don't have to write. So you have 2 of root 5 minus root 2. You can also leave the answer as 2 root 5 minus 2 root 2. You can also leave it like this. 2 root 5 minus 2 root 2. Now what is the denominator? 1, which is clearly rational. The denominator is 1, which is clearly rational. So the takeaway is don't multiply. Don't multiply 6 and root 5, 6 and root 2. Don't multiply. Have it as it is. Now when the denominator happens, see the denominator is 3. 3 and 6 can be simplified. 3 ones are, 3 twos are. So 2 of root 5 minus root 2, which can be written as, you can leave your answer like this, or you can write as 2 root 5 minus 2 root 2. Anything is fine. Yes, children, turn on your videos, all of you. Sanjay and Sindhu. Yeah. All right, children. So that's about the third subdivision. Let's see the fourth one now. In the fourth one, see, this is the given expression. This is the given expression. The conjugate is here the terms are separated by a minus sign. So the conjugate of the denominator, root 3 minus root 5, is root 3 plus root 5. The conjugate of this denominator is this one. So we multiply the numerator and denominator by the conjugate root 3 plus root 5. That is the first step. That's the first step. Next, multiply the numerators, multiply the denominators. So you can see the numerators here. Denominators, when you multiply them, they are of the form a minus b into a plus b, which is a square minus b square, where a is root 3 and b is root 5. A square minus b square. So now we know that root 3 the whole square is root 3 into root 3, which is 3. And root 5 the whole square is root 5 into root 5, which is 5. So 3 minus. So now in the next step, see, the numerator comes as it is. Don't multiply 2 with root 3 and root 5. Don't multiply now. We'll wait for the denominator to happen. Meaning we'll simplify the denominator. See what the denominator is. And then if we want, we'll multiply the, the terms in the numerator. So now 3 minus 5. Write the numerator as it is. 3 minus 5 is minus 2. Minus 2. Now 2 and 2 gets cancelled. 2 and 2 gets cancelled. So we have minus 1 in the denominator. So what do you do in the next step? Take this minus. See now if you have 5 by minus 1. What's the answer? Minus 5. Supposing you get the answer as 5 by minus 1. So that's nothing but minus 5. Similarly here in the denominator, see 2 and 2 gets cancelled. There's minus 1 in the denominator. So take that minus to the numerator. Take that minus sign to the numerator. Like you do here. You take the minus to the numerator and you say minus 5. In the same way, this minus 1 can be ignored. Take the minus up to the numerator. So see 2 and 2 gets cancelled. There's minus, take it to the numerator. So minus, and write this as it is, root 3 plus root 5. Now when you multiply minus root 3, minus into plus minus root 5. Minus root 3 minus root 5. Divided by 1. The denominator is 1. So it's rational now. It was irrational. Now it is rational. So you'll have to rationalize the denominator, you have to multiply and divide by the conjugate. That is one thing. And then in the numerator, don't multiply. We'll just have the numerator as it is. We'll see what we get in the denominator. And if possible, we can simplify. And then we'll multiply. So here also we see that you get 2 in the denominator, so you can cancel. And then this minus is taken to the numerator. And it's applied to every term in the numerator. So see here, we have root 3 plus root 5 in the numerator. You can't just put a minus like this. There are 2 terms in the numerator. So enclose terms in a bracket and the minus should be applied for both the terms. You cannot, in the numerator, we have root 3 plus root 5. You cannot just put a minus like this. No. Root 3 plus root 5. For all the terms here, the minus is applied. So bracket and minus. So it will become minus root 3 minus root 5. Is that fine, children?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
All right. Let's see this one. So again, the conjugate, the denominator is irrational. The conjugate of the denominator is 6 minus 4 root 3. The conjugate, why late, Raja?
Ma'am.
The conjugate of the denominator, yes.
Ma'am, first I joined the class, ma'am. After that I left and came again.
Okay. So 6 minus 4 root 3 is the conjugate. So see here, this is the given expression. 6 minus 4 root 3 by 6 plus 4 root 3. This is the given expression. We multiply and divide by the conjugate 6 minus 4 root 3. Do we understand this step, children? This is the given expression. The next step is write the given expression and multiply the numerator and denominator by it. All right?
Yes, ma'am.
Yes, children? Yeah. Now what do you see in the numerator when you, so this, yeah, the product of the numerators, this numerator into this numerator. What do you see? 6 minus 4 root 3 into 6 minus 4 root 3. A minus B into A minus B is A minus B the whole square. See here, same term, 6, 6, 4 root 3, 4 root 3, minus, minus. A minus B into A minus B is A minus B the whole square. So 6 minus 4 root 3 the whole square. A minus B into A minus B is A minus B the whole square. So 6 minus 4 root 3 the whole square. The denominator is in the form A plus B into A minus B. So A square, this is A square minus B square. This is B square. A6, B is 4 root 3. A squared, 6 squared minus B square, 4 root 3 the whole square. Now in the numerator, we need to simplify using the identity. A minus B the whole square is equal to A square minus 2AB plus B square. Or you can write, or you can say A square plus B square minus 2AB, whatever. A square plus B square minus 2AB. Anyways. So A square, so what is A? A6, B is 4 root 3. A6, B is 4 root 3. A square, 6 square plus B square plus, this is B square minus 2 into A into B. Do we understand that?
Yes,
Children? A minus B the whole square is A, yeah, A6. Oh, good. A6, B is 4 root 3. A squared, 6 squared. B squared, 4 root 3 the whole square. 2AB, 2 into A into B, 4 root 3. 2AB. Okay, so that's what we see here. And in the denominator, A plus B into A minus B is A square minus B square. Now 6 square is 36. And here 4 root 3, 4 root 3 the whole square. How do you simplify? 4 square is 16. Root 3 squared. Root 3 squared meaning root 3 into root 3.
3, ma'am.
I cannot attend to children individually in the class. When you keep your videos turned on, we must know how to present ourselves in front of the video. I'll just remove the student. Whoever is distracting, I'll just remove the student.
Ma'am, we have kept our videos on, but it's
No, Sanjay and Sindhu, no. Your videos, okay, it was not for you. Children, it was not for you. I'm not able to see your video.
ma'am, but we have kept the video on, ma'am.
Really? Others, can you see Sanjay and Sindhu's video?
Yes, ma'am. I can see their
Yes,
video.
ma'am, I can see.
Ma'am, my video is turned on, but it shows off.
Sindhu's video? Why I can't see Sanjay and Sindhu? Okay, I cannot see. Anyways, that was not for the both of you. Ignore it. Yes, children. So now, but I don't know why I'm not able to see you both.
Ma'am, can I try again, ma'am? Can I leave the meeting and come back?
Yes, yes, children, please try. Yeah, now I can see Sanjay.
Yes, ma'am.
Yeah. All right. So, yeah, I was talking about a square minus b square. So 4 root 3. 4 root 3 the whole square. 4 square is 16. Root 3 into root 3 is 3. And 16 3s are 48. So 36 minus 48, which is minus 12. 36 minus 48, which is minus 12. Now in the numerator, you can see you can add 36 and 48. 36 plus 48 is 84 here, 84. And minus 48 root 3 as it is. Minus 48 root 3 as it is divided by minus 12. Now these steps you can do in any order. What I have done is I have taken the minus to the numerator first. See, again, I'll tell you what else you can do. I'll tell you. I have taken the minus to the numerator. So do you understand this step? See here, this minus I've taken it to the numerator. So what should I do? I should enclose the terms in the numerator in a bracket and then put the minus sign before it. Yes or no? Yes or no, children?
Yes, ma'am.
Yes, ma'am.
When you're applying the minus sign to the numerator, please enclose the terms in a bracket and then take the minus before it. So that's what you see here. Divided by 12. Now it becomes a positive 12. Now it becomes a positive 12. So now what happens when you multiply the minus sign with the terms inside the bracket? It becomes minus 84 plus 48 root 3. That's what you see here. Plus 48 root 3 minus 84. Take the minus sign to the numerator. So enclose the terms in the numerator in a bracket and put the minus sign. Minus 84. You can see it here. Minus into minus plus 48 root 3 here. Divided by 12. So in these steps, we have just taken the minus sign up to the numerator. And we got this. We've written the positive term first and then the negative term. First, we wrote the positive 48 root 3 and then the negative 84 divided by 12. Now, in the numerator, 12 is the HCF of 48 and 84. Is 12. That is what is common between 48 and 84, 12. 12 fours are 48, 12 sevens are 84. The HCF of 48 and 84 is 12. So bring out the common factor. Bring out the common factor. So 12 common out. Now 12 fours are 48. Root 3. 12 fours are 48 and then that root 3. 12 sevens are 84. 48 root 3 minus 84. 12 is common. 12 into 4 is 48 and that root 3. Minus this minus 12 sevens are 84. So 4 root 3 minus 7 we get in the bracket divided by 12. 12 and 12 gets cancelled. And the answer is 4 root 3 minus 7. 4 root 3 minus 7. Bracket, you can put the bracket or you don't have to put it. Anything is fine. You may even just remove the bracket. Both are fine. Is this understood, children?
Yes, ma'am.
Yes, ma'am.
All right. So this is the next question. So today, children, in today's class, I'll just explain a few sums. You will take the screenshots and complete it in your classwork later. All right. So just listen to this. Express. So again, you have an expression here with a rational denominator. So the denominator is irrational. Arjun. Arjun. All right, children. So express this one with a rational denominator. With a rational denominator. Okay. So you can see the answer here. Don't read the whole slide. Please follow what I am saying. Okay. So here we begin with this. So this is the given expression. This is the given expression, children. This one. Now the denominator has three terms. The denominator has three terms. What you do, you group the first two terms. You group here, you don't put the bracket. Here you don't put the bracket, I'll tell you. This is what is given to you. This is what is given to you. What you do, you group the first two terms. That is enclose of the three terms, enclose the first two terms in a bracket. So that's the difference you see. You can see here, this is what is given. We have enclosed the first two terms in a bracket. You can see it here. See here, remove this one, remove this one. This is what is given. This is what is given. And what you need to do is, since the denominator, see all the while we've been having only two terms in the denominator. See here, in these expressions, we had only two terms in the denominator. So it was easy to write the conjugate. So it was easy to write the conjugate. So far, in the denominator, we had one term or two terms. Either one or two terms so far. Either we had one term or two terms. Now we have three terms. So when we had one term like this, supposing we had 3 by root 5, only one term, we just multiply the numerator and denominator by root 5. This is how we rationalize the denominator. Then when we had two terms, like in this one, two terms, these two terms, we just change the sign. Minus 6 minus 4 root 3. We just change the signs. We multiply, and that's called the conjugate. And we multiply the numerator and denominator by the conjugate. So far we have seen the denominator with one term or two terms. Now the denominator of this expression has three terms. So what do you do? This is what is given to us. Enclose the first two terms in a bracket. Now it is easy to make out the conjugate. Right, this is the first term. This is the second term separated by a plus sign. So write the same first term, the same second term separated by a minus sign. That will be the conjugate of the denominator. Please watch that. Please watch that. This is the first term. See, this is what is given to us. This is what is given to us. Or we are multiplying the numerator and denominator by the conjugate. So see here, Now, after enclose, there were 3 terms. When you enclose the first 2 terms in a bracket, now this becomes like what? This expression is like the first term, and you can see it here. And this is the second term, root 5. You can see it here. The sign is plus. Now it's minus. So we multiply the numerator and denominator by this expression. Root 3 minus root 2 in bracket minus root 5. I can proceed only if you say that you understood this, children. Enclose the first 2 terms in the bracket.
Yes, ma'am.
In a bracket.
Yes, ma'am.
So now it's like this. Yeah, separated by a plus sign. So write the same terms. See the same thing in the bracket. The same thing separated by a minus sign. All right, children, is this step okay?
Yes, ma'am.
Yes,
Ma'am.
yes, ma'am.
All right. All right. The next step. Multiply the numerators. So when you multiply the numerators, what will happen? This numerator into this numerator. So you'll have to multiply 3. See, this one is just for the sake of identifying where to change the sign, you know. Just to write the conjugate, we put the bracket. But it's the same. This one, the numerator, root 3 minus root 2 minus root 5 is the same as root 3 minus root 2 minus root 5. Please understand that. Though you put a bracket here. See, I'm writing it again. The numerator, root 3 minus root 2 minus root 5. See, we have enclosed these 2 terms in a bracket, right? If you remove the bracket, how will it look like? Root 3 minus root 2 minus root 5. It doesn't make any difference. Even if you remove the bracket, you'll get the same terms outside. So when you multiply the numerators, it will be 3 here, see a 3. And these terms, root 3 minus root 2 minus root 5. Now don't ask me where did this bracket go? It's the same thing. Just take away the bracket. Just to identify the conjugate, we put the bracket there. So now to multiply the numerators, 3 into all this. So it will be 3 into root 3 minus root 2 minus root 5. In the denominator, this is A. This is A. This is B. This is B. This is plus. This is minus. So we have A plus B into A minus B. A square minus B square. This is A. This is A. And this is B. So A square minus B square. See here, A square. Root 3 minus root 2 is A square minus root 5 is B. Root 5 is the whole square. This one is A. This one is A. So square it. Square it. See here, A square. Minus, identity, it's minus B square. This is B. Root 5 is B. B square. Because the denominator is like A plus B. See, now don't get confused. This whole thing is A. Don't read this as what is this? This is a minus. How are you saying this as A? The whole thing. Don't read this at all. This full thing is A. This full thing is A. So A square. Whatever is A, write it and square it. Minus, this is B. This one is B. Write B and square it. This is A plus B into A minus B. So as always, we will not multiply the numerator. Meaning we'll not do 3 root 3 minus 3 root 2 minus 3 root 5. We will not do that. We will not do that. We'll have it as it is. We'll have it as it is. We'll write the same news here. The same numerator comes down. We'll only simplify the denominator. We'll only simplify the denominator. Now look at the denominator. Now the denominator, this one is like A minus B the whole square. So you can see here A square plus B square minus 2AB. And then this minus root 5 the whole square is minus 5 because root 5 into root 5 is 5. This is now A minus B the whole square. A square plus B square minus 2AB. And then this minus root 5 the whole square, which is 5, minus 5. Next step, write the same numerator. And root 3 square is 3. Root 2 square is 2. 2 into root 3 into root 2 is 2 root 6. Because root 3 into root 2 is root of 3 into 2, which is root 6. 2 root 6. Minus 5 outside the bracket. Minus 5. Now 3 plus 2 is 5. Minus 2 root 6. Minus 5. Plus 5 minus 5 gets cancelled. So we are left with minus 2 root 6 in the denominator. Minus 2 root 6 in the denominator. Write the same numerator. See, the same numerator comes. The same numerator. 5 plus 5 minus 5 gets cancelled and minus 2 root 6 remains in the denominator. Now the question you need to ask yourself is the denominator rational? Answer the question. Is the denominator rational?
No, ma'am. No, ma'am.
No,
What
ma'am.
makes it irrational? What makes the denominator irrational?
2 root 6, ma'am.
No, in 2 root 6, what is irrational?
Root 6, ma'am.
Root 6 makes the denominator irrational. Root 6 minus 2 root 6. Minus 2 is rational. Root 6 is irrational. So minus 2 root 6 is irrational. So that root 6 makes it irrational. This of course, the entire thing is irrational. If you take minus 2 separately, it is rational. Root 6 separately, it is irrational. Minus 2 is rational. Root 6 is irrational. But when you multiply, minus 2 root 6 is irrational. The whole thing is irrational. So the denominator is irrational. And you know that minus 2 root 6, minus 2 and root 6, they are separable. You can separate the two. You can write minus 2 separately and root 6 separately. So it's enough if you multiply and divide by root 6. You don't have to multiply and divide by 2 root 6. It's enough if you multiply and divide by root 6. Because when it's multiplication, the rational factor and irrational factor, they are separable. If it's 2 plus root 6, you have to multiply and divide by 2 minus root 6. You cannot separate 2 and root 6. If it was 2 plus root 6, then you have to multiply and divide by 2 minus root 6. But in 2 root 6 is separable from 2. So it's enough if you multiply and divide by root 6. Now let's multiply. Now children, I'll tell you one thing. Okay, supposing I'm here and you're reading somewhere here and you didn't understand. Okay, you didn't understand. Say you didn't understand. I would have then, so when you're here, like, so you did not listen to me. When I'm teaching here, you are here. When I'm teaching here, you are here. When I'm teaching here, you are here. And when I'm teaching here, you finished it and you didn't understand. And then when you didn't understand and you come back to, my explanation, I'll be here. But you wouldn't have understood all this because you were not listening. So it's very important because you can see the entire answer on your screen. Don't read through the answer, please. Let's go together. Let's go together. Please, we'll all go together. It's not that you have to listen to me. We'll all travel together. We'll not race one another. Yeah. So that, see, when I'm explaining this and you're listening to this, so this is tick, you've understood. When I'm explaining this and you're also listening to this and you don't understand something, you can immediately get your doubt clarified. You can immediately ask me your doubt. When I'm teaching this step and you're listening to this one, same thing. If you understand, good. If you don't understand, immediately you can ask your doubt. If I'm here and you are here, you are in trouble. If when I'm teaching this and you are here, you will be in trouble. Don't put yourself in trouble. Now, yeah, so, yes, children? Yes? Somebody wants to say something? Okay. All right, children. So now we multiply. We multiply the numerators now. So what happens? This 3, let it remain outside. Let it remain outside. Root 3 into root 6 is root 18. Root 2 into root 6 is root 12. Root 5 into root 6 is root 30. I'll repeat that. This 3, we have to multiply. We'll have to multiply all this. We have to multiply the numerators. This one with root 6. So how to multiply? I'm writing this 3 as it is. I'm multiplying the terms in this bracket with root 6. I'm multiplying the terms in this bracket with root 6. So this 3 out here, this 3 out here. Root 3 into root 6 is root 18. Root 2 into root 6 is root 12. Of course, my signs, you know what to put. Root 5 into root 6 is root 30. Divided by minus 2 into root 6 into root 6 is 6. Now, we need to check if all these surds can be expressed as mixed surds. Or we need to check if these surds, which look like pure, which present themselves now as pure surds, you should see if you can express them as mixed surds. For that, you should find the prime factors of these numbers. So that's what is the next step. That is what is the next step. You can see 18 is written as 2 into 3 into 3. Because 2 3s are 6, 6 3s are 18, 2 2s are 4, 4 3s are 12. And 30, you'll wonder why she didn't write 30. Because 30 is 2 3s are 6, 6 5s are 30. Only one factor, no, 1 2, 1 3, 1 5. Anyways, nothing will come out. If you want, you can write. See, there's no harm. You can write here 2 into 3 into 5. No harm in that. You can write that. And then in the next step, you can put back root 30. You can do that, children. Maybe I'll do that for you now. This root 30 instead of this root 30, children, you can write because we cannot process everything instantly, no? So you can write 2 3 of 6 6 5 30. You can instead of this. Now next you can see here from 2 3s 1 3 comes out. From 2 3s 1 3 comes out, 3 root 2. From 2 2s 1 2 comes out, root 3. And from here, from this one, nothing comes out because only 1 2 1 3 and 1 5. So we put back root 30. Am I clear, children?
Yes, ma'am.
All right.
Yes, ma'am.
Okay. All right, children. So we put it back. We put back root 30 because the prime factors, they don't occur in pairs. So we just put back root 30. Okay. Now in the denominator, we have minus 2 into 6, which becomes minus 12. And now you can simplify. You can simplify here also. 3 1s are 3 2s are 6. You can do it here also. You can do 3 1s are 3 2s are here also. I have multiplied minus 2 into 6 is minus 12. And then I've cancelled. Here 3 1s are 3 4s are. Watch carefully. Watch it carefully. I hope you understood. All this is to write, if possible, as mixed surds. So this one, root 18 can be written as a mixed surd. Root 12 can be written as a mixed surd. Root 30 is a pure surd. It cannot be expressed as a mixed surd. Divided by minus 12. 3 1s are 3 4s are. So minus 4. In the numerator, the 3 is gone. The 3 is gone in the numerator. It's cancelled with 12. This is gone. This is gone. 3 is gone. Okay, 3 1s are 3 minus 4 times. So now this one 3 root 2 minus 2 root 3 minus root 30 divided by minus 4. Now what is that? Whenever the denominator has a minus sign, we carry it up to the numerator. And when we carry it up to the numerator, if there is more than one term in the numerator, we enclose the terms in a bracket. When the denominator carries a negative sign, we take the negative sign up to the numerator, and in the numerator, if there is more than one term, we enclose the terms in a bracket and then prefix the minus sign. That's what we have done. We put this in a bracket and taken the minus sign. We prefix the minus sign. That is what you see here. All these terms in a bracket here. and this minus is taken out to the numerator, so minus, and the denominator becomes a positive 4. Now multiply the minus sign. Minus 3 root 2, you can see it here. Minus into minus plus 2 root 3, positive, so I've written it first. And when you multiply minus into minus root 30, it becomes plus root 30. Divided by 4. This mic is enabled. Rishmika Shri. Yeah, thank you. All the children. Yeah, so we took the minus to the numerator and then we multiplied the minus sign with all the terms in the numerator. We wrote the positive terms first. Just start with one positive term. Then you can write this also first. Anything. When you're writing, you can also write the negative term first. It's not that you'll not get marks or you lose marks. Nothing like that. Minus 3 root 2. I've written it here. Minus into minus plus 2 root 3 plus 2 root 3. Minus into minus plus root 30. Divided by 4. Now what is the denominator, children? What is the denominator in the final step? 4. 4. Is 4 rational or irrational? Rational. Yeah, so we have rationalized the denominator. Earlier, what denominator after this first stage, what was the denominator? After doing this, what was the denominator?
Minus 2 root 6.
Minus 2 root 6. Yeah, minus 2 root 6. Correct. Wherein root 6 is still irrational. So we had to proceed. We couldn't stop there because when you looked at the denominator was still irrational. So continue. Again, use the rationalizing factor. Root 6. Multiply and divide by root 6 and proceed. So now you can see the denominator is rational. So we have answered the question. We have expressed with a rational denominator. So children, take a screenshot of this one. I don't want you to write this bracket here. And then I want you to show the factors. 2 3s are 6, 6 5s are 30. I want you to show it here. With these two changes, please take the screenshot.
Done, ma'am.
Taken, ma'am. Taken, ma'am.
All right, children. All right, children. So this is the next question. Find the values of a and b if 3 plus root 2 by 3 minus root 2 is equal to a plus b root 2. So let's go back to this one. Now supposing it was given, find the here, supposing this was given to be equal to say a root 3 plus b. Please understand, suppose this expression was given to be equal to a root 3 plus b. And if you had to find the values of a and b. So the procedure is the same. How will you rationalize this denominator here? Same procedure you'll have to adopt. And what answer you got? 4 root 3? You got 4 root 3 minus 7. and that's given to be equal to a root 3 plus b. So you should compare the two sides. So when you compare both the sides, now see here we have this is equal to a root 3 plus b. So it's like this answer is equal to a root 3 plus b. So when you compare both sides, you see that a root 3 equal to 3. The irrational is equal to the irrational. This irrational and this irrational. A root 3. A root 3, when you, on comparing the LHS and RHS, A root 3 is equal to 4 root 3. A root 3 is equal to 4 root 3. So root 3 gets cancelled. A is equal to 4. And then B is equal to minus 7. The rational is equal to the rational. B is equal to minus 7. Children, supposing this was given to be equal to A root 3 minus 7 and we have, sorry, minus B, and we had, okay, plus B I said earlier, anything. So supposing this expression was given to be equal to A root 3 plus B, and if the heading was find the values of A and B, same procedure we have to adopt, same procedure. What answer we get? 4 root 3 minus 7. Now this is equal to A root 3 plus B. Compare the two sides. This is the LHS. This is the RHS. A root 3 is equal to 4 root 3. So A is equal to 4 and B is equal to minus 7. Yes, but I'll give you time to go through the answer. Please go through, children. See how it is presented. This is given. This is given. Okay, this one is given. Then for this one, for this expression, we need to this a plus b root 2 simply comes as it is a plus b root 2, a plus b root 2, a plus b root 2. So everything is happening only in the LHS. Where is it where is something happening? That something or everything is happening only in the LHS, nothing in the RHS. RHS is simply a plus b root 2, a plus b root 2, a plus b root 2. You simply keep writing it till the denominator is rationalized. So here to the LHS, see the RH is a plus b root 2. This is given. The RH is a plus b root 2. We have just write it as it is till the end. What happens in the LHS? We find the the conjugate of the denominator. We multiply and divide by the conjugate. So that usual procedure is happening in the LHS. That usual procedure is happening in the LHS. So please watch out for that and get your doubts clarified. So that will bring you to this step. Once you rationalize, you'll be here. Once the denominator is rationalized, it will bring you to this step. You will be here. Now 11 plus 6 root. So when should you stop? What denominator is rationalized? So all that is happening, rationalizing process is happening in these steps. And here you're done with the simplification and the denominator is rational now. Now compare both the sides. To compare both the sides, since you have the denominator 7, write it as 11 by 7 plus 6 root 2 by 7. 11 by 7 plus 6 root 2 by 7. You know all this. A plus B by 2 is A by 2 plus B by 2. Or if you have A plus B minus C plus D by 2, it's nothing but A by 2 plus B by 2 minus C by 2 plus D by 2. So write it as 11 by 7 plus 6 root 2 by 7. 11 by 7, 6 root 2 by 7. Why plus sign? Because there in the numerator, the connector is plus. It's plus. Now compare the two sides. Now compare the two sides. See, on comparing, A is equal to 11 by 7. And when you compare this and this, this and this, what will happen? Root 2 and root 2 will get cancelled. So B is equal to 6 by 7. B is equal to 6 by 7. See here, A is equal to 11 by 7. Then B root 2 is equal to 6 root 2 by 7. Okay, you will wonder why you're cancelling the root 2. Okay, when this root 2 will come to the other side for division, right? The root 2 will come to the other side for division. Let me write it here. B root 2 is equal to 6 root 2 by 7. Now, how will you find the value of B? Root 2 will come to the other side for division. Root 2 will come down for division into root 2. This root 2 from here will come to the other side for division. Now root 2 and root 2 will get cancelled. So B is equal to 6 by 7. So that's what I said. B root 2 is equal to 6 root 2 by 7. Root 2 and root 2 will get cancelled, and B is equal to 6 by 7. Am I clear, children?
Yes, ma'am.
Yes,
ma'am.
Yes, ma'am.
So can you help yourself with this one?
Yes, ma'am.
Yeah,
Yes,
can you take a screenshot, children?
Done.
Yeah.
Taken, ma'am.
Taken, ma'am.
All right, children. Yeah, now this is a test. Work this now and be the first to give the answer. Done writing the question?
Yes, ma'am.
Yeah, start working. Let me see what you're all doing. If you're finished, you can, if possible, take a picture and share your answer on WhatsApp. Take a photo of your answer and put it on WhatsApp for me.
Yes, ma'am.
Yeah. Yes, what are the values of A and B?
Ma'am, I'm still working.
Okay.
Still doing, ma'am.
Fine.
Value of A is 4 and B is 7, ma'am. No, 2, ma'am.
Ma'am, I too got the same answer, ma'am.
Yes, ma'am.
I'm missing Sanjay and Sindhu today. Why I'm not able to see your video?
Ma'am, but they have kept their videos on only, ma'am.
That's what others are able to see you. I'm not able to see you both. That's what I'm saying. I'm missing you both today.
Ma'am, I'll leave the meeting and try again, ma'am.
Hey, children. Just Pranjit and somebody else give the answer. What's the value of A? 4. Huh? And B? 2.
Yes, ma'am. Ma'am.
Who else got that?
Ma'am, I also got the same.
Both of you? Yeah, Sanjay, I can see you. Yes. Yes, Sanjay. 4 and 2 is it?
Yes, ma'am.
Yes, ma'am.
Very good. Very good. Let's see. I'll just unshare my screen. I'll unshare my screen.
Yes, ma'am.
Oh no, I have a different answer. My God, have I gone wrong in working?
Ma'am, it's A is equal to 9 and then B is 2, ma'am.
A is equal to
9, ma'am.
and B?
2, ma'am.
No. Somewhat right, but not completely. Very good, Krishmi.
Ma'am, can I share the answer?
Yes, 1 second. I've got Krishmi's working on WhatsApp. Very good, Krishmi. Neat work. Very good, very good. Your answer is right. So Krishmi's got the right answer. Yes, somebody wanted to share. Was it Madhumita?
Yes, ma'am. I got 9 by A is equal to 9 by 2 and B is equal to 2 by 2.
2 by 2, huh? That is
Yes.
1.
Yes, ma'am.
9 by 2 is right, but not 2 by 2.
Okay, ma'am.
Yes, it's time. One student has finished, so let's see the answer. Can you see my screen again, children?
Yes, ma'am. Yes, ma'am.
Okay, Prajit, you have shared your answer. Let me see.
Yes, ma'am.
Prajit, A minus B the whole square is A square plus B square. You've written minus B square.
Okay, ma'am. I'll correct it, ma'am.
Yeah, 11 minus 7. That's where you've gone wrong. Otherwise, you would have got it right.
Ma'am, I've
Understood your mistake?
written 11 minus 7 only.
All right.
Yes, ma'am.
That's not Ling. It's not 11 minus 7. A square plus B square minus 2AB. You have written A square minus B square minus 2AB.
Yes, ma'am. I got it, ma'am.
Yeah. A square plus B square minus 2AB. Very good project and Krishmi, Sri Krishmi. Yeah, others check your answer and see where you've gone wrong. Okay. I'll tell you your mistake, Amadimita. Okay, I where you've gone wrong. I'll tell you.
Yes, ma'am.
Yeah. Same mistake, Sindhu. Who's ever working it is Sanjay and Sindhu. I'll tell you, yeah.
Now I understand my mistake, ma'am.
Okay. All right, children. So, you know, here we have gone wrong. If we cannot cancel like this, we cannot say 4, you know, like 2 2s are and 2 9s are. You cannot cancel. There's a minus sign here. This whole thing, they're not separable. You cannot look at them separately. You cannot look at, you know, like they make one expression. You cannot take 4 and 18 and simplify, or 2 and 4 and simplify. If it's multiplication, you can do, but not with addition and subtraction. Okay, so what you can do is you can take out 2 common. See here, after this step, what if you have not worked the way I have worked, what you can do is you can take out 2 common. Then in the bracket you will get 9 minus root 77 by 4. You can take out 2 common, then you will get 9 minus root 77 by 4. Now you can cancel 2 1s are 2 2s are. This you can cancel because it's multiplication here. Then it will become 9 minus root 77 by 2. That is nothing but 9 by 2 minus root 77 by 2. So on comparing both the sides, A is equal to 9 by 2 and B is equal to 1 by 2. What I have done is I've taken the denominator 18 by 4 minus 2 root 77 by 4. So this becomes 9 by 2. This becomes root 77 by 2. Root 77 by 2 is nothing but half root 77. Half root 77. Root 77 by 2 is half root 77. So that means A is equal to 9 by 2 and B root 77 is equal to minus half root 77. Sorry, minus B root 77 is minus half root 77. Here A is equal to 9 by 2. Minus B root 77 is equal to minus half root 77. So root 77 on both the sides gets cancelled. Minus on both the sides gets cancelled. B is equal to 1 by 2. So remember, children, you cannot cancel like this. We cannot do this. 2 9s are, 2 2s are, then 2 1s are and 2 1s are like this. We cannot do this. It's wrong. I'm saying we cannot do this. We cannot cancel 4 and 18 because this is one term. The connector is a minus. So the mistake is we have cancelled this one. 2s are, 9s are, and then this 2 and 2. That's why we got some of us got a different answer. Take a screenshot, children.
Ma'am, can you explain the third step alone, ma'am, once again?
Which one? Here,
Third
this
step,
one?
ma'am.
This one?
Yes, ma'am.
Yeah, A minus B the whole square, right? So a square plus b square minus 2ab.
Okay.
Where a, this is a minus b.
Okay.
This is a minus b the whole square, where a is root 11 and b is root 7. So a square plus b square minus 2ab. A minus b the whole square.
Yeah, ma'am. Thank you.
Take the screenshot, children. Please complete all this in
Taken,
your. Yeah.
Taken, ma'am.
Yeah. Children, today you must excuse me. I'll be winding up the meeting now. Just have to attend to some other work. Please excuse. This also will be your homework. Take a screenshot of the question and please complete this.
Taken, ma'am.
Yeah. I'll be sending you an assignment based on this one, where we have 3 terms in the denominator. This one. I'll be sending you 2 more questions like this. 2 questions like this, where we have 3 terms in the denominator. Use the same procedure to rationalize.
Yes, ma'am.
Yeah. So what you have to do is you'll have to complete your classwork, then complete also, meaning complete your classwork with the screenshots you've taken today, and also this one as homework.
Okay.
2 more questions I'll post.
Yes, ma'am.
If suppose you have not taken a screenshot, it's here. Okay. Yeah, today's meeting, I know I started late and I'm winding up early. We couldn't do much today. So please complete your homework so that it'll be like as if you have learned a lot today. I'll send the homework. Please complete it. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you.
Thank you, ma'am. Thank you, ma'am.
Thank you, children.